Hello, I am Hannah Donnett with the Collaborative on Health and the Environment. Che enjoys bringing you the latest environmental health science through our partnership calls, webinars, science surfs, publications, and social media. I would like to welcome everyone to today's Che EDC Strategies Partnership webinar, which is titled, Are Fluoropolymers Really a Low Concern for Human and Environmental Health and Separate from Other PFAS? Our moderator today is Cheryl Patton, Director of Commonweal Biomonitoring Resource Center. We will leave time following the presentation for a brief Q&A session. You may type in questions to the Q&A feature available on the menu bar at the top of your window at any point during the presentation. After the presentation, our moderator will read out questions for our speakers to respond to. We will get to as many comments and questions as we can during the Q&A period. For those of you who called in on the phone, we have posted slides to accompany today's webinar on our website. You can download these by going to healthandenvironment.org. Please scroll to the bottom of the page and select today's webinar. On the webinar page is a link to the slides. Everyone on the webinar right now is muted with the exception of our moderator and our speaker. The webinar is scheduled to last for 30 minutes and is being recorded for our call and webinar archive. With that, I'll turn things over to you, Cheryl.
Thanks so much, Hannah. And I'm completely delighted to introduce to you all our speaker for this session today. Dr. Lohmann is professor of oceanography at the University of Rhode Island and has studied source use, transport, and toxicity of chemicals in waterways and oceans around the globe for many years. Proving clearly that these chemicals are contaminating food webs and lingering for decades. He studied water contamination from Narragansett Bay to the Arctic Ocean, and it's even located some of these chemicals in mother's milk from fur seals. And as we all know, almost everyone in the United States has body burdens of PFAS chemicals, and babies are actually born pre-polluted with PFAS chemicals. So Dr. Lohmann is really concerned about this, of course, and interested in the regulatory process because many of these chemicals he has studied have been banned or tightly regulated for more than 40 years. Now, PFAS is currently undergoing regulation in different states, but it's been known to be toxic for many years, and that it's still out there. And in all our bodies and waterways is not a good idea. Dr. Lohmann heads up the Superfund research at the University of Rhode Island and oversees a remarkable amount of research, including, for example, with his students developing a method to test for PFAS in waterways using a plastic sheet. Perhaps we'll hear more about that. He's also a member of the Global PFAS Science Panel, which has published a remarkable set of papers concerning PFAS regulation, uses, concepts of essentiality, persistence, and so on. And this paper he'll talk about today is among those publications. He's going to address fluoropolymers, but they should really be considered polymers of low concern, because if they are, then they are out there not necessarily needing to be regulated. And I'm not going to go into with the details of his talk, because I think we're going to go over right now into Dr. Lohmann and turn it over to him and talk about whether or not fluoropolymers are polymers of low concern. Thank you.
Thank you very much, Cheryl. Thank you, Che, for inviting me. So I'll talk about this, our recent paper. There's a lot of co-authors. I will not go through all of them. So with a group effort, part of the Global PFAS Science Panel. So a brief introduction. I'll talk about what fluoropolymers are, why they might be of low concern, then how they are made and why that needs processing aids, the problems that might arise from their production in terms of losses of monomers, oligomers, or others. We know about toxicity and maybe uptake by organisms, problems at the end of life cycle with persistent disposal, and then really finally goes down to should they be produced without any restrictions. So in the big scheme of the class of PFAS, we have the non-polymers. That's the one we normally are aware of. The perfluoroalkyl substances, so the PFAA, PFOS, and the like, the polyfluoroalkyl substances, or the precursors, those that have hydrogens and can break down and then produce perfluoroalkyl substances in return. And then on the other side, we have the polymers. And there's a big category of fluoropolymers, which I'll talk about. There are also perfluoropolyethers, so compounds, polymers that have oxygens in their backbone, and then side-chain fluorinated polymers. Those are known to lose side chains over time and cause pollution. There's a quick introduction here from Bruno Ameduri from France, who is a big proponent of fluoropolymer uses. And he forecasts a bright future, increasing sales, increasing production, increasing complexity of the fluoropolymers that are being used. And if you're interested in all the uses, then look up some of his latest papers. So fluoropolymers, should they be of low concern? So this is actually a regulatory distinction that some polymers don't really need to undergo certain regulatory requirements because they are of low concern. You can easily imagine that industry probably had a major hand in crafting such legislation, and probably was meant for something like polyethylene or polypropylene, I'm just guessing. And so a bunch of scientists, mostly on the industry side and associated consultancies, came up with this idea that fluoropolymers should qualify for the same loopholes to avoid too much regulation. That was 2 years ago. So then I led a team from the Global PFAS Science Panel. Cheryl was one of the many co-authors, to figure out what we actually think, whether that's a suitable approach for regulating or not regulating fluoropolymers. And so you can read some of the details in this article in ES&T. And I think our simple solution, or not solution, our simple answer to this problem is, this is all what happens to fluoropolymers. They get produced from simple ingredients that have to be sourced from somewhere else, get produced fluoropolymers. At this stage, you have emissions and exposure of communities and the environment. You turn them into products. Again, at this stage, during use, you have emissions, exposures. You have the end part where you have the disposal, where depending on where you go, you probably have emissions. And so the big life cycle is complex and messy and probably has a lot of losses. If you try to argue for a low concern status of these fluoropolymers, you can only do that if you look at a very specific time point and find a clean product and say, oh, this product is so nice, there's no harm, and you ignore all the rest of the life cycle. So quick word on what fluoropolymers actually are. The majority is PTFE or Teflon, that's over half, and then you see some other major fluoropolymers include polyvinylidene fluoride, polyvinyl fluoride, and so on. Somewhere is Nephion in here. Nephion we'll talk about again because it's one of those where we actually see some of the byproducts in the environment. Production of fluoropolymers is not small at 320,000 tons a year, but given the overall polymer production of 300 million tons, that is still a niche product, luckily, at this point. So a quick word on definitions that become important as we talk through some of these things. The fluoropolymer substance are really the well-defined polymers with a well-defined structure. So that's like PTFE, so Teflon-like, or whatever. The product is what the manufacturers produce and then sell, and that could be one of those many fluoropolymer manufacturers. And so they produce maybe a granulate, a fine powder, and sell that onto manufacturers or users. And those then turn it into products that we're more familiar with, like a Teflon-coated frying pan, a rain jacket like a Gore-Tex jacket, and other membranes that impart oil or stain repellency. And then we have different processes of making these products. And that is actually important because not all ways of making fluoropolymers require processing aids, but some do. And that's an important distinction because the processing aids, as I'll talk about next slide, are what so far is linked to the large contamination of manufacturing sites. And then we have very diverse products of the fluoropolymers, be that granulates, powders, or dispersion. So it's a very heterogeneous family of fluoropolymer products out there. So a quick word on the production side. And it turns out a lot of the contamination that we are aware of PFAS is linked to the production of fluoropolymers. So the most obvious example is probably West Virginia, DuPont's manufacturing and use of P4 to make Teflon. And that, of course, has resulted in a major blockbuster movie where Waters, but also we have a documentary, The Devil We Know. We had the major scientific breakthrough study, the CH study, looking at 70,000 people and effects of PFAS on their well-being, or PFAA on their well-being. We have in New Jersey, PFNA was used as a processing aid, and that again has contaminated the groundwater and the environment in that region, leading to legal challenges from the state to rein in, and of course, very strict drinking water guidelines for PFNA. So the history of those major well-known processing aids is very bad, and even led EPA to phase out the production of these chemicals in the EU, US, and I think Japan. But In China, PFAA is actually still allowed to be used. So it's well possible that you import an article, a consumer product or whatever else that still has PFAA in it because it was used by a manufacturer outside of this stewardship agreement. Of course, as I said, the worst chemicals, PFAA, PFNA, are not produced anymore. So industry switched to replacements. And it turns out there are some of these wonderful structures. There is the Gen X chemicals that have been detected in North Carolina and the Netherlands in the environment in drinking water. So the environmental footprint hasn't really improved that much. There's also stories of this polyfluoropolyether that has a chlorine substitution that has been observed in a river in Italy and in New Jersey, and that was published in Science a few months ago. And of course, New Jersey is now also again suing Solvay and Arkema because of their use of novel processing aids that again ended up contaminating the environment. There are a couple more. There's a cyclic structure up here that has been found in the Veneto region in in groundwater and in rivers. And there's another one, Adona, that was detected in the River Rhine and serum samples of workers. So overall, we can really say the replacement chemistry have been handled just as badly by manufacturers of fluoropolymers as the legacy compounds because they are all already out. Is that all that we are worried about? No, because we know there are other byproducts that can escape production, and some of them are going to be very volatile, which means they're difficult to capture and remove. And some of those fluorine-containing chemicals are known to have very greenhouse gas potential, which of course is not the thing we want to release into the environment at this time when temperatures are already rising very fast. A study by James McCord from EPA that detected various oligomers and stack emissions. There's a slightly older study from Decatur, Alabama, detecting a series of polyfluoroalkyl carboxylic acids. And lastly, or lately, Chemours in North Carolina, forced by regulatory decree, had to identify compounds in their waste effluents. And they found over 250 unknown PFAS structures that are part of their waste stream that was in water. And I think they still have to do the same for the atmospheric emissions. So basically the production leads to a wide range of emissions, most of which we don't really know what it is. We have some detects, but it's not all that we are. There's more out there than we know at this point. And maybe last example, this is the detection of Naphthalene byproduct 2. This could be even from the use of the Naphthalene membrane, and there are some other PFO5 dodecanoic acids. So that's one of those polyether carboxylic acids. They have been detected in fish, birds, humans in the region of North Carolina in particular, but also beyond. So a lot of these products are out there and are accumulating in places like humans and animals we don't want them to be. Is that all? There's probably more, because even in the finished Teflon products, so where Teflon is used, there are residuals left, and those will leach out. And for those of us who do analytical chemistry, we are always battling the problem that in the HPLC side, there are Teflon products used and other fluoropolymers that lose some of the PFAA over time, so we have background contamination. And so it's not a big scratch to realize that even other products that have Teflon and other fluoropolymers will lose some of the residuals that are in there and get lost and might contaminate food and humans. In the Henry paper, where they argued that fluoropolymers are safe, they said that's because we take really aggressive steps to wash out residuals and drive off volatiles. So it sounds like a very good thing. The only catch is that it's now well known that several sites are very contaminated by these aggressive steps of drying Teflon. And in the US, North Bennington, Merrimack, Hoosick Falls, all were not primary producers of fluoropolymers, but used particularly Teflon to make other products. And in the process, they lost PFAA probably through atmospheric emissions. And so again, the use of these processing aids is troublesome because clearly the industry has not found a way of keeping them within the applications. Toxicity-wise, Philippe Grandjean spoke to Jay a few days ago. We know PFAA, PFNA have horrible effects. That is well known. The new HFPODA, so the Gen X chemical, is also toxic, doesn't bioaccumulate as much. We don't know as much for the others, but we know some of them have been found in serum, so it's not looking good. And there's a reason for why we're worried about the toxicity of the new chemicals just as much, because to be effective as processing aids, they need to have similar properties to the PFAA, PFNAs. And with that, they probably also have similar toxicological profiles, and we know that just as persistent. The other claim that was made in the paper to argue for this status of reduced regulatory oversight is that polymers are too large to penetrate cell membranes. And basically there are several studies from the micro nanoparticle literature that suggest that is not true anymore. Particles on the size of tens of nanometers can and have been shown to enter cells. So just to say we don't have to worry about polymers just because they're too large and cannot enter cells is not correct anymore. We note, however, that fluoropolymers are only a very small part of all the polymer production in the world. Having said that, there's several studies out that actually show by now that Teflon microparticles have been detected and confirmed in fish in the Mediterranean and in remote Arctic sediments. So as any other polymers, they disperse over long distances. And because fluoropolymers are extremely persistent, more so than the typical consumer polymers we deal with, it's no big surprise that we find them in remote locations. And of course, that will continue to increase over time. We do acknowledge that the toxicity of plastics or nanoplastics is current research that's ongoing, and we don't know the effects. So moving on, what happens at the end of life cycle? Well, the one thing we do know is that fluoropolymers are extremely persistent because of their chemical makeup. Recycling is really only happening at the industrial scale, which seems like a good thing. Waste and scraps are turned into even smaller particles. They're called fluoroadditives, added to uses such as in bicycle chain lubricants. But there's very little possibility of recovering and recycling fluoropolymers in consumer articles. So they basically just have to be dumped or burned. Once they're landfills, we know PFAS are on leachates. There's ongoing research how to intercept them. Incineration, it's unclear what's happening to all the PFASs. At high temperature, we probably destroy them all, but we have evidence that there's other byproducts formed that nobody knows right now what they are. So based on that, we suggest that really the production of these fluorinated polymers should really only occur in what is essential uses for the safety and functioning of society. Can we make this case that fluoropolymers are very different from PFASs that are used as processing aids? And really at this point, we can't. In North Carolina, GenX was a major contamination. In the Netherlands, the same. It is possible to produce PFAS without these processing aids, but industry so far hasn't switched over to that kind of production. So I'm running out of time slowly, so let me get towards the end. Are they really of low or high concern? We think there's no reason to say they're of low concern. Given everything we know about them, they should really be of high concern. And you can't resolve the PFAS problem if you don't work on how fluoropolymers are produced. So I think one way we approach this is to say, if you have to use them, at least use them in closed loop technical systems and avoid losses, and otherwise only have them for essential use categories. So I think my 15 minutes are up. So we think they should actually be heavily regulated because of the history of contaminating production sites. And I think my take on it is that we should think of them as conjoined twins. Right now, you kind of fluoropolymers without the use of low molecular weight PFAS, which are the compounds we are concerned with for human health and the environment. Thank you very much.
Thank you very much for that excellent presentation. And you covered a great deal of information in your 15-minute time slot. And we do have some questions coming here from Carolina Robkova. In order to phase out PFAS and all the byproducts and emissions from fluoropolymers, would you suggest to ban the fluoropolymers as such instead of individual chemicals containing organic fluorine?
That's a tough question. So if you actually go through where fluoropolymers are used, I think some of them are used in essential gear for firefighters and medical personnel, but they're also used in solar panels. So I don't think we can, as much as I would like to, I don't think we can ban them straight away. We would have to put an emphasis on finding alternatives that are much safer. And we have smart chemists and engineers. It must be possible. So I would hope you set something like a sunset clause, you know, let them produce for a little while longer, make sure they stop emitting all the horrible products into their wastewater streams and through their chimneys. But say, all right, for a few more years, yes, but then eventually you have to find something better. Yeah. That won't be my hope.
Okay, thank you. What kind of substances or breakdown chemicals would you recommend to monitor in human bodies to track down the contamination?
That's a tough one, because typically in human serum concentrations are low of chemicals other than the ones we're looking for. I think the North Carolina region is probably the best because they already found some of the naphthalene byproducts in humans, and Gen X itself was not found, or the Gen X chemicals. It probably depends on where you live. If you live next to one of those fluoropolymer production sites, you should probably look at some of the compounds that are now have been discovered by often EPA scientists actually. And that includes the naphthalene byproducts, but also the Washington paper showed some cyclic and some chlorinated versions of PFASs. And the sad part with the chlorine substitution that it actually makes them stronger by accumulating. So they're actually stronger tendency to end up in humans too.
So when we biomonitor people, we're usually looking at PFAS chemicals in serum, but we know some of the short-chained chemicals that are usually eliminated in urine, we're not going to be picking up in the serum itself. And some of those might be ending up in human organs, lung, heart, bone, and so on. Do you advocate doing some more testing around the short-chain, how we can figure out how fastly they're going through the body actually, and whether people are being exposed to them by looking at actual human organs or organs and sea mammals or whatever? Because I think we're not capturing actually exposures to short chain.
It's a great question and comment. We know short chains are kind of the worst of both worlds because they're much more difficult to filter out of water, and we can't biomonitor for them as easily. So I think looking at urine might actually be a good idea. It probably is also just a matter of making sure we check our drinking water in areas of concern, particularly to make sure we don't have an abundance of short chain compounds that might be just as bad. We just don't know how to measure them well right now.
Yeah, yeah. So sometimes the effluent from wastewater treatment plants actually increases the amount of PFAS. And some recent research done by Access Labs is indicating that what's showing up in the effluent is larger amounts of long-chain PFAS chemicals like C12, 14, 16, and they're not going beyond that. Any comment about that? Because I don't think anybody's biomonitoring for these longer chain ones in human bodies at this point. And as you know, the effluent is often used, they call it biosolids, and it's used for fertilizer on land. And sometimes it's just that they try to clarify it, clean it up from salt and other chemicals, but it could re-enter the water stream as it does in Southern California.
And populations that rely heavily on seafood, like some of the Arctic communities, you find an abundance, a higher proportion of these long chain acids because they bioaccumulate strongly. Mm-hmm. And so that would be where you would need to pay attention, make sure that they are not ending up in the humans. But yeah, that's certainly a concern.
Okay, just a comment from Linda Birnbaum. She says it's a beautiful talk, and she's looking forward to getting the slides. But she asked the question, what do you need to accomplish rather than just think about in terms of chemical replacement?
We have a great history of regrettable substitutions in the US, and I don't know how to turn this around. Clearly, the TSCA reform hasn't really changed the way things are, hasn't changed enough to make a big difference. I would hope that similar to the EU, when you start thinking about circular economy or sustainable chemistry, you have to get away from any chemical that outlasts us in terms of being in the environment for years and decades. So if you're able to come to consensus that you don't want to produce those anymore, that would be a major step forward. I mean, it doesn't solve all the chemical problems, but it would at least take away all the concerns about all the horrible persistent compounds. And that includes basically all PFAS.
Yes, thank you. Kaylin McDermott, is there any information available on the absorption or removal of fluoropolymers? How can these be removed in processes of drinking water? Do they have similar properties to PFO and PFAS when it comes to sorption?
Yeah, that's a good question. So if we think of fluoropolymers indeed as polymers, so as small particles, we know that micro and nanoparticles are partially removed in treatment plants, but not sufficiently. As I was trying to say, I don't think we are very clear on how bad and what modes of action these micro nanoparticles have for humans or animals, but it's a major research area right now, and hopefully that'll help us figure out where to direct our attention in that regard.
All right, thank you. You commented a little bit about this, but there's another question about what really happens to fluoropolymers in incineration, and the typical temperatures around 850 degrees centigrade. Who's really measuring that? Is that really working?
Yes, I think the only studies out so far are often with industry collaborators. That doesn't mean that they're wrong. It suggests that some of the PFAA and PFAS are probably not stable, but the studies haven't really looked at what other products are coming out of the chimneys. And we know from the dioxin work from decades that all kinds of nasty byproducts can be formed, and some of them can be very stable. So we have to expect that there's things coming out. I think EPA is starting to look at some of those emissions, particularly relevant now that some communities might be sitting right next to an incinerator that might burn off AFFF. So I think it's of concern, and you have to look for a wide range of unknown compounds at this point and just see what you can detect.
Mm-hmm, mm-hmm. And another question, what about structural fires? When homes these days are full of plastics, but also televisions and computers and other apparatus devices that are using circuit boards, which use a lot of PFAS chemicals. The temperatures of those fires are not going to be around 850 degrees centigrade, but they will be up there, maybe 400 degrees centigrade often can happen. What would you expect in the smoke particles around a wildland urban interface fire to have PFAS chemicals attached to smoke particles?
Wow, so yeah, smoldering is probably the worst possible way of dealing with waste, and it creates a lot of nasty substances, be that particles, pHs, dioxins. I don't think we know enough about if we have now suddenly compounds that are partially fluorinated. I assume that what will happen, they'll have some chlorine, they'll have fluorine sprinkled in. Typically fluorine stuff makes it more recalcitrant, so it's probably nothing good. But other than that, I don't know what I could predict.
Okay, thank you very much. I think we're just about to end our time here, and Hannah's showing the slide indicating that we need to wrap things up. So I want to thank you for a really excellent presentation, and thank you also everyone for your excellent questions. And I know, Rainer, you'll be working on this issue for quite some time, and we hope to invite you back again at some point for updates and progress on how we can all deal with this very serious chemical and the exposures related to it, and the health outcomes related, especially in terms of immunotoxicity, vaccinations, and the COVID virus. So thanks once again. Really appreciate all the work. Thank you. Okay, Hannah, I'm going to turn it back to you.
Great. Just thank you so much, Dr. Lohmann and Charles, for moderating. We're approaching the end of today's webinar. A video recording will be available on CHE's website soon. Tomorrow, you'll receive an email containing a link to the video as well. The next CHE and Boston University Superfund Research Program Partnership webinar will take place next week, Tuesday, December 8th. Then on Thursday, December 10th, we will host the third webinar on our Generation Chemical Partnership series titled How Chemicals and Air Pollution Are Harming Fertility, the Latest in Evidence and What We Can Do. You can find details on our website at healthandenvironment.org. If you are new to CHE and would like to stay updated about upcoming events or more, please sign up to receive our newsletter by selecting the Join Us tab at the top of any page on our website at healthandenvironment.org. Additionally, if you appreciate these CHE partnership webinars bringing you the latest environmental health research for free, we encourage you to support CHE's ongoing work by making a tax-deductible donation via our secure website. Again, our website is healthandenvironment.org. With that, I would like to thank our speaker, Dr. Lohmann, for taking time to present today, and to you, Cheryl, for your excellent moderation. Thank you so much for joining us. We are wishing all health and wellness, and have a great day.